All right, so let's do another example of this just to get some practice. Let's say I gave us the number of this. All right. So that looks like it's 49,300,000. And so let's write that in exponential notation. So remember, we take all of the numbers or all the digits that we have that are non-zero and write them here. Okay? Now, everything to the right of this 3 are zeros. Therefore, I don't need to deal with anything further than this over here at the moment. Okay? Now we multiply it. Again, this is not a variable x. It actually means multiplication here. Times 10 to the question mark, 10 to the something. All right. So here's a very important thing that we need to remember. Whenever we have finished writing all of our non-zero digits here, we always need to put a decimal point just to the right of the first digit. So there can only be one digit to the left of the decimal point. Okay, now let's see how many times we need to move the decimal point to the right to get this entire number represented. All right, so if we have the decimal point here, we need to multiply by 10, 100, 1,000, 10,000, 100,000, million, 10 million. All right, so I was just saying the places, but really all you need to do is count the number of times that you're moving in terms of this little hump. So it's 1, 2, 3, 4, 5, 6, 7. All right, again, 10 to the 7th. So 4.93 times 10 to the 7th is the correct scientific notation of 49,300,000. All right, let's do another one quickly. Maybe one where we won't get 10 to the 7th again. That was just complete coincidence. So how about let's do 3201 with a lot of zeros. All right, so here we go. All right, so what's the first thing that we do to take the standard form or the standard number and put it into scientific notation? We write all of the non-zero digits up until the point that it just becomes zeros. So we have 3201, all right? And then it's going to be multiplied by some power of 10. And also remember that we need to put this decimal point in here, okay? So there's only going to be one digit to the left of the decimal point, all right? So if I were to start with this decimal point here, how many humps do I need to go? Or how many powers of 10 do I need to multiply against this number to get back to this original number or the standard form? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this case, it would take 10. So 3.201 times 10 to the 10th is the correct scientific notation of representing this standard form.